In this section 2.8, techniques for finding the derivatives, we are going to use the sum and the different rule to find the derivative of a function. We're going to find the slope of a tangent line to a function at a given point, and then we're going to find the equation of the tangent line to find a function at a given point. This section we focus on using the rule to find the derivative, and then use a derivative to find the slope of the tangent line. That means we are going to find the derivative at a given point, and then we can use that as a slope to find the equation of the tangent line at that given point. Let's look at the sum and the different rule. The first one is called the constant multiple rule. The key term constant multiple rule, the constant means the C coefficient here, and then multiply to the function, which is f of x. The derivative of the y, or the y prime, is c, which is the constant multiple to the derivative of the function, or the f prime. Sum and different rule. In the case that the function has multiple terms are separated by plus or minus sign. If you have two terms, the derivative of the y is the sum of those two derivative terms. Same thing as when you have the difference, like y equals f minus g, then the y prime is f prime minus g prime. Next, let's see the examples. In these examples, we are going to use the various rule of differentiation. That means we can use the basic rules from the previous section together with the constant multiple and the sum the different rules that we see in this section to find the derivative for each of the following functions. For part A, we have the function y as 1/3 times x to the third plus 5 square root x minus 7. Recall one of the basic rule that we saw in the previous section is called the power rule. The power rule means if you are looking, I'm going to write here, power rule for the power function. That means if y equals x to the power r, so the y prime is the power r will become the coefficient and multiply by x to the power r minus 1. That's the power rule. This is one of the most used rule for the derivatives. So for part A, we have three terms, 1, 2, 3. As a sum and difference term, you have three terms. That means you are going to find the derivative of each term and add them up, or add or subtract them, depends on the operator that you have for that problem. So for the first one, we have y equals 1/3. So 1/3 here is called the constant multiple times the function, which is x to the power r. The r is 3. The second term is the constant multiple, which is 5 as a c, times x to the power. We don't see the power. That means we have to convert this into the power 1/2, because power 1/2 is the second root or the square root. And the last term is the constant term. So this one is a constant. As we identify the type of each term, gonna help us make a connection to the rule that we're gonna apply to find the derivative. So I'm gonna rewrite it in the way that easier to find the derivative term by term. So this is 1/3 times x to the power third, which is nothing changes, plus 5 times x to the power 1/2, and then minus 7. Therefore, when we find the derivative of y prime, going to be term by term, 1/3 of the constant multiple, the derivative of x to the third, which is 3, times x to the power 3 minus 1 by applying the power rule. And then plus the next term, the constant multiple 5, times the derivative, which is 1/2, times x to the power 1/2 minus 1. And subtracted by the derivative of the constant, which is 0. And then we just simplify as much as we can. So for the first one, I'm going to change to the color red. So 3 and 3 reduce. And then 3 minus 1 becomes 2. That means the first term now becomes x to the power second. The second term, 5 and 1/2 multiply, or rewrite it into the simpler term to be 5 over 2 times x to the power 1 half minus 1, that is negative 1 half. So then the final power is negative 1 half here. And minus 0, you can ignore that term. So we get the derivative of part A. If the problem asks you to rewrite in the non-negative power, the first term already non-negative power, second or the power 2 here, but the second term, you can rewrite the negative power as the reciprocal of the positive power, and then simplify to the most simplified form as x squared plus 5 times 1 becomes 5 as a numerator. Denominator is 2 times x to the 1 half, where x to the power 1 half is the same as square root x. Therefore, the very most simplified one will be x squared plus 5 divided by 2 square root x. So this is the non-negative power form, but this one is acceptable when you do the exam. Alright, that's part A. Next one, we are going to find the derivative of the function y as the product of the quantity x squared plus 1 and the quantity 2 minus x. At this point of time, we do not have the product rule to find the derivative. So we just go back to the basic by rewriting the product into the sum using the distributive property or the FOIL technique, the FOIL that you learned in the algebra class. So first times first, we get 2x squared. Outer times outer, we get negative x squared times x becomes x to the third power. Inner times inner, we get 1 times 2 becomes 2. Last times last, which is 1 times negative 1 becomes negative x. Now we have 1, 2, 3, 4, 4 terms. Then we're going to use the sum and different rule to find the derivative. As we notice, each one in a form of constant multiple, the power form, and power form, the constant term, and this one technically to the power first. So we find the derivative term by term. So the y prime equals the constant multiple, the derivative of x squared, which is 2x to the first, because we subtract the power 2 by 1, subtracted by x to the power 3, the derivative is 3x to the power 3 minus 1 becomes power 2. And then the constant 2 here, the derivative is 0. And the last one, the derivative going to be 1 times x to the power 0, or just negative 1. Next, we just simplify as much as we can. 2 times 2, that's 4 times x, minus 3 times x squared. We can disregard the 0 and then bring the negative 1 into the term. So we get y prime as 4x minus 3x squared minus 1. Now, we look at part C. Part C is, now it's in the quotient form. Again, at this point, we do not have the quotient rule, so we're going to go back to the basic by simplifying algebraically. This one we can simplify as make sure everything in the power form. The numerator already in the power, but the denominator is in the radical form. So now we change it to the t to the power 1/3. And then this is the form of, it has a single denominator. That means we can separate them by each term sharing the same denominator. After that, we use the exponent property. If you recall, a to the power m divided by a to the power n, you can rewrite as a to the power m minus n. For this case, the first term, t to the power 2 on the top, 1/3 on the bottom, adjusted to be t to the power 2 minus 1/3. The second one is 3 times t to the power negative 1/3 by bringing the denominator up, the power chain to the negative. 3 is treated as a constant multiple. That means the function y now is simplified to be t to the power of 5 over 3. from subtracting 2 and 1/3. And the next term is 3 times t to the negative 1/3. We have the power form, we have the constant multiplied by the power function form. So we do the derivative using the sum the different rule. The first one, the power r is 5/3, treat it as a coefficient, and then the t now, the new power is 5/3 minus 1. Added by the next term, constant multiple 3, times the derivative of t to the negative 1/3, which is negative 1/3, times t to the negative 1/3 minus 1. Simplify as much as we can. The first term becomes 5/3 times t to the power 2/3 or 2/3. The second term, we can see that the coefficient can be simplified and will give you the coefficient negative 1. You can omit 1, so just have negative side there, times negative 1 times t to the power, now it's negative 4/3. And at this point, we have the derivative of the function y in part C. Again, if you are asked to rewrite the power as a non-negative power, the first term, nothing that you can do, just rewrite it to be 5/3 times t to the power 2/3. But the second term, its negative power, we rewrite as a reciprocal with the positive power like this form. And you're done. You get another form of the solution.